So the next presentation is by Alex Hall and Fran Kramer from the US EPA Office of Research and Development. It's entitled, they've been working on a number of things related to private wells, and it's really exciting what they've got going. They're not able to share everything that they're developing, but they will be able to soon. Today we're going to hear about how they're using this information in identifying problems around leaking underground storage tanks. And the title of their talk today is Underground Storage Tanks and Implications for Private Domestic Wells.
Hi, this is Fran Kramer and Alex Hall from US EPA's Office of Research and Development, and we're based out of Cincinnati, Ohio. We're in the Center for Emergency Response and Environmental Solutions and serve in ORD as the research arm for the agency. We're happy to have this discussion with you about looking at underground storage tanks and potential implications for private domestic wells. We've just released UsFinder, which is a tool that we'll walk through today to show you some of the features in there to consider about where tanks are relative to private domestic wells, and as well how to think about other geospatial information in the context of private domestic wells. So we'll cover, in general, off the top, just looking at some of the implications for public water supply expansion and what that means relative to the private domestic wells, and then jump into discussion about the geospatial data, both our tanks data and then very briefly about other array of data that's available through US EPA to look at contaminant sources relative to private domestic wells. We'll then jump into a discussion about a new approach we've developed on determining well density at a national level, and then move into a discussion about flooding and implication for domestic wells. And then last but not least, we'll do a demo on UsFinder to show you the application itself. So in developing UsFinder, we until now haven't had really a national database that compiled all the state data on underground storage tanks. The tanks program is a state delegated program, and every state manages this data and manages the prevention and cleanup sites of this data set. And so this has been the first time really that this has been curated and developed into a tool that we could see this at a national level. And as well, this data is important too for states to understand where in particular they may have facilities on the borders of the states that may be impacting resources, water resources, or soil impacts across the border. And so it gives a better lens to understanding the potential transport implications across these borders. So as you can see here, it's a lot of data that's contained in the database, some 2.2 million underground storage tanks at 800,000 facilities. And we are looking at nationally 6 billion gallons of fuel that's stored in the underground storage tanks. Our impacts that we're looking at, of course, encompasses groundwater, both public water supplies and private water supplies, and then also implications that may be there due to petroleum vapor intrusion as well. And then lastly here, we'll cover as well the impacts potentially on extreme weather and how that can impact the movement of contamination from our sites, both spatially and temporally. So addressing the importance of public water supply infrastructure, as you may know, and certainly the folks who are engaged in private domestic wells are tuned into what these impacts may mean with regard to their water supplies and the need for private domestic wells. The U.S. public water systems are heavily impacted by two major issues. One is the infrastructure itself, the aging infrastructure, and the financing for the capital improvements for this. And again, as this community knows, where we have dispersed housing or small towns, there are significant infrastructure issues and economic challenges in providing public drinking water supplies for these communities. So we very much rely on the private domestic wells. These water infrastructure investments are by and large supported by the state and local governments. There's obviously some federal funding that goes into it, but it's really our frontline defense is the state and local government. And then in terms of the actual funds that are allocated, we're really just staying apace of providing the needed maintenance on these systems. And that spending really is just focused principally on that, given, of course, the aging infrastructure that we do have. So with the decline in capital investments, it's certainly for the near term going to be continued, if not expanding, reliance on private domestic wells. You may have heard about a current effort with regard to infrastructure proposal that's looking to be funded up to $100 billion. Obviously very much in discussion at this point and debate, but in there specifically there is $10 billion that's allocated to look at the forever toxic chemicals. That's a separate category, but that line item, as you'll see here, is also investment in rural water systems. So obviously there may be some hope here in the next year or so to move some of that funding to improve public water supplies in rural areas. The next slide here gives you a representation of the data that's found in UsFinder. Again, the first national snapshot that we've had of underground storage tank. This is specifically focused on leaking underground storage tanks across the U.S. Likewise, here you can see where in general we have a higher density of population. We're going to have higher density of leaking underground storage tanks as well. But what you'll find in this data set too, what is unique, we also have in many of our large cities where the core of the public water supply is stopping. This is where we're picking up private wells and a higher density of private wells in proximity to these cities. And so it's what we found is really a donut effect around cities in the country where the private domestic wells have this higher density in the suburban or exurban areas. I also want to bring your attention to another data set that the US EPA has. While our focus today is on underground storage tanks, there's also a great repository of geospatial data pertaining to Superfund sites, a variety of RCRA facilities as well. And you can look in here and really start to pinpoint where these sources may be. And as we go through the presentation here today, you can better understand how we can use this type of information as well to complement existing information on the private domestic wells.
Thanks, Fran. I'll jump in here. I wanted to give kind of a brief background on a data set that EPA ORD created. And it's really an updated map, an assessment, a data set of where our private domestic wells are located both at a block group geography and a block geography. The impetus for this effort is around the fact that the census, the 1990 census was really the last time we had a national assessment of where our private domestic wells are located. In 1990, the census asked, in its long form census, where do you get your water supply from, public or private sources? And that was the last time that question was asked. So here at the EPA, we set out to update those estimates or that data and estimate 2010 private domestic well use and density. We use two methods. Both are based on the baseline 1990 census. What we did is we took those numbers at the block and block group level, and we updated it by looking at housing unit change over the 20-year period. And we took individual driller well logs from I believe 23 states, and we incorporated the housing unit change and the driller logs to get a better, more up-to-date estimate of where our private domestic well universe is. And this data is, and we'll show you here in a bit, informs some of the information within UsFinder. We want to know where our private domestic wells are in proximity to underground storage tanks and leaking underground storage tanks. And broadly speaking, 17% of the country roughly gets their water from private supply. This is not ubiquitous across states. This map just shows the percent population served by domestic supply, and this ranges a lot from North Carolina at 38% down to Hawaii at basically 0. So depending where you are in the country, the percent of the population and the number of wells constructed changes drastically. Now let's look at the proximity to private water resources, and in particular, let's look at our leaking underground storage tanks. There are about 64,000 active leaking underground storage tanks in this country. There are a lot of private domestic wells in proximity to these. Nationally, we estimate that there's about 250,000 private domestic wells within 1,500 feet of our leaking underground storage tank universe. And this map on the left shows the number of private wells near this leaking underground storage tank universe by state. And again, we see big differences between states. Just looking at Florida alone, we've got we estimate about 58,000 private domestic wells co-located near leaking underground storage tanks.
And then to shift more specifically into the contaminants of concern from the leaking underground storage tanks, we're principally concerned about BTEX. This is benzene, toluene, ethylbenzene, and xylene, where we have maximum contaminant levels that designate the needed concentrations that need to be achieved for drinking water standards. So if we look at our MCLs, which benzene is the most restrictive, we're sitting at 5 micrograms per liter for benzene. And if you look at gasoline fuel composition, we're at some 6,000 milligrams per liter. Alternatively, then, what this translates into, if we just look at the ratio of the fuel composition and the benzene in particular to the MCL, we need to be in some dilution factor of over 1 million. It would have to be before it would reach a private domestic well. And I say dilution, it could be any other attenuation mechanism. But in many cases, the concern is that we have to reach that million factor to get down to an acceptable level. And so in the private domestic wells, the concern obviously is there's going to be health effects well before there would be any taste or odor threshold that would be experienced by a homeowner. Our thresholds are sitting in orders of magnitude above the actual MCL for benzene. So this is certainly one of the big drivers that we have in the cleanup program, and certainly what calls our attention to this issue. So one of the key reasons that we had focused on developing an approach for the private well density is for really understanding the density of the private domestic wells in proximity to our underground storage tanks. So we had a good means to assess what are the targets that we need to achieve to prevent impacts to private domestic wells in proximity to our facilities. I wanted to also give perspective too. So while we think about, in many cases, a more static site conceptual model of our facilities relative to wells, be it a public water supply well or private domestic well, indeed, it's really not a static system. So I just want to show you just the representation here, how we would look at some different pumping scenarios along with contaminant sources. So on the left-hand side here, if you would envision the 4 red dots are sources of contamination, could be gas stations at an intersection. So you would have a specific pumping regime where some of the contamination is going to the north and some to the south. However, on the right side, if you change that pumping regime to where another well is being added and pumped at a very high rate, you're really altering the transport of those contaminants, and those indeed could be drawn in exclusively to that third well with that high withdrawal rate. So how we look at our public health at a state and local level, we need to be cognizant of what these demands are on the wells and what they in turn mean with regard to contaminant sources and the cleanup levels that we need to achieve to protect these water resources in proximity to our facilities. Wanted to cover a bit too here with regard to issues impacting extreme weather events and how this plays into understanding private domestic wells. So you think, well, how does this possibly impact my well? I think the reality is with climate change and new data that's increasingly coming out with regard to the severity and the frequency of these events, we need to stay tuned into what are these floods' impact on our wells. This just shows you information that NOAA has recently released from data on 2020 and the extreme weather events and the costs that we're seeing throughout the country. And of course, a lot of this is causing inundation in these areas. In the next slide, you'll just see as well a couple examples that we're going to walk through in terms of the types of flooding. For those in coastal areas, you probably already know, and particularly on the eastern seaboard and the southeast, days where high tide flooding occurs and the frequency of those occurrences. On the left-hand side here, you'll just see visually an array of cities and the increasing frequency of high tide flooding that's occurred over the last 60 years. So this is a trend that it will be increasing in frequency, and one that we need to be thinking about with regard to not only where our private domestic wells are, but where also our facilities are located, because when we have this flooding, then we're also getting contaminant transport moving further and faster than where we would have normally anticipated it. Equally important too is then how do we think about drought conditions and what this means for our wells and our supplies. So in terms of the drought conditions, and this is a snapshot just taken within the last week or so of the drought that's occurring out west. Again, these are staggering numbers that are coming in on the drought monitor. To see these conditions this in springtime, this early, doesn't portend well with regard to conditions there. On the right-hand side, they are also, this is NOAA, USDA, and the National Drought Information Center have developed an approach here that's still in a beta form, but nonetheless, it gives you a great synopsis of what are some of the long-term trends that we're going to be seeing with regard to more wet conditions and dry conditions. So while we think of increasing temperatures and drought, we also know regionally there are going to be significant changes in precipitation that are going to be occurring, and we need to attune to those conditions as well at a regional, state, and local level. In the next slide, then, just very briefly to review in terms of the types of flooding. Certainly the media catches a lot of attention on the river flooding and the pluvial flooding. In many cities, we've seen such extreme precipitation that the storm systems can't accommodate this level of precipitation, which results in flooding in these, particularly urban, suburban areas. As I just described too, just in terms of the coastal floods, ones that we obviously need to be paying attention to. The one that's of these four types of flooding that doesn't get much attention is really the groundwater floods. And for us in our community here for private domestic wells, this is an important one. And this could be due to any of these other factors in terms of the pluvial floods or river floods and coastal floods. It's going to change the groundwater levels. And so we need to stay tuned into this to protect the private domestic wells.
then I'll jump in here and just kind of further talk about floodplains and their proximity to our leaking underground storage tank universe and our underground storage tank universe. Really, water is the nemesis of our tank systems. It can cause microbially induced corrosion. It can foul fuel. It can cause corrosion on both the inside and outside of the tanks. And here in this picture at the bottom right, there's a quote from somebody seeing that a tank literally popped out of the ground and was floating down a river due to buoyancy issues. Nationally, because we collected all this underground storage tank data, we could now really assess, well, how many of our underground storage tanks were within floodplains. We found that there were about 33,000 underground storage tanks within FEMA's 100-year floodplain, and that's about the equivalent of about 250 million gallons of fuel or hazardous substances. And here we can just look at the number of tanks by state within floodplains, and you can see a lot of them up in the Northeast and California, Texas, Florida.
And then to bring this to a state level, Wisconsin's been doing a great job in looking at precipitation and what this means with regard to groundwater levels. And this is a depiction here just for a given county in Wisconsin that looks at the probability of occurrence. And so what they're seeing, and again, it's even differences within the state, but they're seeing groundwater levels at levels that they've not seen in the past. So when we are considering this data, this means several things to us. One is where we have contamination that exists in our facilities where the groundwater level is increasing. This can generate mobilization of contaminants within the groundwater. And then two, importantly, with regard to vapor intrusion, so certainly for our state and local public health folks in attendance, the vapor intrusion component is equally important to us because as the contaminants are mobilized in the groundwater, we need some separation distance between the bottom of a structure and the groundwater to prevent vapors from advancing into the residential or business structures. Then again, looking at a given site and where our contamination could reside, and again, we're speaking most specifically about underground storage tanks that are leaking. Where we have leaks at these sites and have extensive precipitation that's occurring, we know that these plumes can go deeper and farther than what we would have anticipated under more normal conditions. And so we are very tuned in from a site characterization and a monitoring point of view to be able to adequately document where these plumes are going. Likewise, this data is important for private domestic well owners, that we have the proper distance from potential sources of contamination to prevent them from reaching private domestic wells.
Thanks, Fran. In the interest of time, I think we've got about 5 minutes left here. I'm going to jump in and just quickly give a demonstration of UsFinder, and just that this is a tool that's publicly available. I encourage people to visit it. It's the first national database of our underground storage tank and leaking underground storage tank database. It's hosted on EPA's Geo platform. Lots of data included in it. We've got 2.2 million tanks. We've got over 500,000 releases, both active and closed. Here we're just looking at the facility data aggregated by county. Things get more detailed when we zoom in. We can zoom in here and let's look at Indianapolis. And here are our individual underground storage tank facilities. Again, this is a novel and unique application and collection of data. We went to all 50 states and collected state database to get this 2018 to 2020 snapshot, and we've got data on two different states, something that hadn't been done before. Here we're looking at the facilities. The light blue dots here show facilities where all the underground storage tanks have been closed. We thought we included this information deliberately. Sometimes tanks are removed or sites are closed and there can still be contamination on site. The blue dots here represent active facilities. We can get more information about the individual facilities. We know that there's 3 active or open underground storage tanks at this facility. We estimate how many people live nearby. People are receptors in case there's a release. We estimate that there's 71 people within 1,500 feet. Very relevant to this conference. We estimate for all 500,000 releases and all 800,000 facilities, how many private domestic wells are within 1,500 feet? Now we estimate here that there's about 17 private domestic wells nearby. That's looking at the kind of the private wells, but what's also important are the public wells, the public receptors. We identify for every site if they're within a source water protection area. Here it is not, and then we also look at whether a site is within a wellhead protection area. This is meaning that it's near a public drinking water intake. We also identify whether the site is within a floodplain or not. Now we can get more information about the individual USTs at that site. We can click a few buttons here, and this is kind of the tabular data of the individual tanks. We can look at the tank ID, the status, the installation data of the tank. If we have removal dates, we have it. We include it, and capacities, if we have it, we include it. And then we also have the substances stored. That's the kind of the facility and underground storage tank side. We can also look at the leaking underground storage tanks. The light pink are closed tanks. Closed leaking underground storage tank sites, and the dark red points here represent active leaking underground storage tanks. And just like with the facility layer, we can get more information about it. We have the reported date. We have how many people live nearby, the wells nearby, and the like. There's some tools in here that help us kind of really triage the data quickly. We can say, well, for all of our leaking underground storage tank sites, find me the sites that have at least 40 private domestic wells nearby. And I can just toggle that. And then it returns the information that, every one of these sites, these active or closed leaking underground storage tank sites, have at least 40 private domestic wells nearby. Important information to know if we're concerned about water contamination and consumption by the public. There's a lot of tools in here, and there's a lot of data in here. I would encourage you to explore it. But I think I'll end it there. And thanks for your time, and thanks for joining the session.
Thank you, Fran and Alex, and thanks for joining us today. We probably have time for one question, and we have one that I will throw up on the screen here, and you can see that in theory. And nope, that's not it. Hang on just a second. I got to the wrong one.
Well, we can answer that when you're pulling together in terms of.
Yeah, go ahead.
The seismic data, yeah, we're very much tuned into that. And as you suggest, the injection wells are driving a lot of that activity. So yes, that's one of the things we're looking forward to including as another data layer.
Okay, there is one other question here. Somebody must have taken a question down if you can do that. I thought I read a different one, but all right.
Yeah, so the data can be downloaded. Just Google Us Finder, and it'll take you to an Office of Leaking Underground Storage Tank landing page. And then you can go and download the tabular data. If your state agency or environmental health agency has a GeoPlatform account or has an Esri account, you can actually pull in the service, the underground storage tank, leaking underground storage tank data, into whatever mapping application you're using. So it's easily transferable.
All right. And I'm excited. The work that you're doing is going to lead eventually to some better estimates, hopefully, of the number of private wells we actually have in the country, which, we're all aware of the 1990 census being the last time, and it's a frustration for a lot of folks. So I think the work you're doing is really important, and look forward to whatever else comes out of all this. Yeah. So, all right, thank you.
Okay, thank you. Appreciate the conference and the invitation.
Yeah, and if you get an opportunity, if you're gonna stick around, when you get into the regular part of the conference, you can, if there's any more questions. Someone asked about how to provide the data and ArcGIS and some other things, so you can answer them in the chat. All right.
All right.
Thank you.
Appreciate it.